Hello guys, welcome to another practical session with Mr. Moses. So for today, we'll be looking at the verification of Ohm's Law. Now, the Ohm's Law tells us that the voltage supply is directly proportional to the current. That means an increasing value of the voltage gives a corresponding increase in the value of the current. Meaning, once the voltage supply is increasing, the current too in the circuit is also increasing. So today we'll be using a set of practical procedures to be able to understand the existentiality of the Ohm's law. So join me as I take you on this switch ride into the verification of the Ohm's law using simple practical procedures. To verify the Ohm's law, we'll be using a set of apparatus. The first one I would like to talk about is our power supply. The power supply will be giving us the amount of voltage, and by increasing or decreasing the knob, we'll be able to increase the voltage from 2 to 10 or 12. Okay, then also we will have our cable for connection, our wires, which we'll be using for connection. Then we'll be having our ammeter. Here's our ammeter. Then we'll also be having our voltmeter and our standard 1 ohm resistor. And also for cross-checking, we will also be using our digital multimeter for the experiment. So in the next procedure, I'll be showing us how we are going to be making use of all of these apparatus shown us here to make our simple connection for the verification of Ohm's law. So guys, following our practical procedure, this is the experimental diagram for our setup. This is the diagram for our experimental setup. We have our ammeter, which is A. You are seeing it in A, is in series with the voltage supply, and the ammeter is in series with the resistor. The ammeter is in series with the 1 ohm resistor, and the voltmeter is in parallel with the resistor. So firstly, we connect our power supply. This is our power source here. It is connected to this our DC power supply. Ensure it is switched off before you start your connection. Then we have this clip, one at the negative and the other one at the positive. So from there we connect it to the ammeter. We connect the red, that means the positive, to the red point of the ammeter. Then we connect this, the negative part, you can see the wire, to our 1 ohm resistor. Then from the 1 ohm resistor we connect this wire to the voltmeter here. Then we connect from the voltmeter, the negative side of the voltmeter, to the other terminal of the 1 ohm resistor. Then we connect it back. Then we connect it back again to the output, which is this negative part of our DC. Now to check if this is working very fine, to check our connection, then we will switch on the power supply. Now when I switch on the power supply is at 0. Okay, so you see at 2, look at the voltmeter, look at our voltmeter, look at it. Then you record the value of your voltmeter. The value of our voltmeter here is 0.4. Our ammeter here is reading 280. It's written 260 milliampere. Then when I increase our voltage supply to 4, then you see our ammeter increases again. Our ammeter increases. We record the value of our ammeter, which is 680. Then the voltage is 0.7. So you see that when we keep on increasing the values, as we increase the voltage supply, the voltage across the 1 ohm resistor also increase, and the value for the current in the circuit also increase. So you see that we have been able to verify that as we increase the voltage supplied, the current too also increase. So with an increasing voltage supply, there is also an increasing value of the current in the circuit. This is being seen by our ammeter. So our ammeter gives us the reading of the current supplied, the current flowing in the circuit, and the voltmeter tells us the voltage across the 1 ohms resistor. So we have been able to verify the Ohm's law that with an increasing value of the voltage supply, there is also an increasing value of the current flowing through the circuit.